today's day and age, data is everywhere, from Google to your favorite browser, scientific research papers, to your favorite webpage. It's all in all of them. But what can you actually do with data, since it's just numbers? It turns out one of the most important things you can do with data is to model it. This allows you to see what all the data is telling you, but how would you even begin doing something like this?
Normally, when you model data, you take a guess at what kind of function fits the data, and then you define that function. For example, here the case might be y equals mx plus b. And then you change the constants around the function so that the function fits to the data points the best. So in this example, it might be y equals 0.7, x plus 0.5. And this fits pretty well. This is more generally called a parametric regression function. So there's lots of different parametric regression functions, but they all have the same idea. You adjust constants around a normal function so that you can fit data well. But these have shortcomings because sometimes you don't know what the data you're using function looks like. So for example, let's take this case where the data doesn't really appear to be any normal sort of function, and we don't really know what it function is. So we need a way to model this data, even though we don't really know what function will fit.
Luckily, mathematicians have already found an answer to this problem. It's called a Gaussian process. But if Gaussian process doesn't use a parametric regression function, then how does it work?
So a Gaussian process takes an input or x value and maps it to a probability function for output or y value. So here, it takes an input and given the data points, defines how probable each output is, or y value. And so there's a 68% chance that the output will lie within that range and 11% chance that it will lie within this range. And so we can do that for all inputs and x values, and we'll get something like this. And this is not yet a function though, since it doesn't put a y value output. It doesn't give a number for an output. So instead of using this, we'll just draw a line through the most likely y values or outputs for each given x value or input. And so you can do that. And this approach is better than the parametric regression function because it allows you to use any function no matter if you don't know what the function actually looks like, because it just uses probabilities given by the inputs and defines the outputs based on those probabilities rather than forcing a function to look like that.
So now you understand the fundamental ideas behind Gaussian processes. Thank you for watching.